Hello, welcome to Zelin's A-level class, and today we are going to do identities in trigonometry. So what is identities? Well, identities are something that always true. For example, 3 congruence to 3, and that is an identity. So however, most of the questions like we are going to meet in the exams can't be solved just by looking. So like we won't get some questions like 3 congruence to 3. We will get some questions that we need some algebra, doing some algebra and some simplifying. So let's do a simple question, which is we learned this in AS level. Sin x plus tan x congruence to this thing. And let's just, because we know that tangent x is equals to sine x over cosine x, which means sine x plus sine x over cosine x. So left hand side equals this, and that is equal to cosine x, sine x, cosine x plus sine x. And that is equal to cosine x, so sine x bracket cosine x plus 1 over cosine x, which is equal to right hand side. And that is a very simple identity question. And now we are going to do some more complicated questions. Well, this is A-level questions we are going to meet. However, well, in my opinion, this part is never easy. So let's change this word into hard. And let's do this question. 1 minus tangent squared a congruence to cosine 2a times secant squared a. And now let's look at this. So our left hand side equals 1 minus tangent squared a. And because here is related to cosine, so which means we should change tangent into cosine or sine form. So how do we change? Well, we can use this again. Tangent x is equal to sine x over cosine x, which is equals to 1 minus sine squared x over cosine squared. A over cosine squared a. And that is, and let's simplify this, which becomes cosine squared a minus sine squared a. And that is equal, because we know the double angle formula, which means cosine squared a minus sine squared a is equal to cosine 2a, which means that this is equal to cosine 2a over cosine squared a. And this is equal to cosine 2a times cosine squared a over 1 over cosine squared a. And because of this, we know that this is equal to secant squared a, which means that this cosine 2a times this is equal to cosine 2a times secant squared a. And this is equals to right hand side. So this is, it's actually quite okay, I think, because you don't need a lot of things. You just need to expand this and do some, use some formulas. Okay, so now let's move up to medium level questions. Well, according to here, we said it's hard questions. So let's change medium into harder questions. And let's look at this question. 1 minus tangent squared a over 1 plus tangent squared a congruence to cosine 2a. So the same thing, let's start from left hand side, which is equals to 1 minus tangent squared a over 1 plus tangent squared a. And because here is cosine here and here is tangent here, so our aim is to change tangent into cosine, which becomes 1 minus sine squared a over cosine squared a. Here is 1 plus sine squared a over cosine squared a. And now that is equal to, let's simplify this, which becomes cosine squared a minus sine squared a over cosine squared a. And here is cosine squared a plus sine squared a over cosine squared a. And now we know that this is equal to 1, which means that, and here we can use the double angle formula, which becomes cosine 2a over cosine squared a. And here becomes 1 over cosine squared a. And let's simplify this, becomes cosine squared a cosine 2a times cosine squared a. And let's cancel these two signs. And this is equal to cosine 2a, which obviously it's our answer. And that is equal to right hand side. And our proving is finished. So now let's move to another medium question. And it is this question. So the same thing, when you are doing identities, you always start from one side. So left hand side equals sine 4a over sine a. And here, let's consider here. This is cosine a, this is cosine a, which means, and here is cosine 4a. So our aim is to change 4a into the same type as in right hand side. So let's change sine 4 into the form of sine a. So how do we change this? We can use double angle again, which becomes 2 sine 2a cosine 2a over sine a. However, here is 2a, which is still not what we want. So we need to change this again using the double angle formula. And this is becoming 2 times 2 sine a cosine a. And here cosine a will become cosine squared a minus sine squared a over sine a. And now, because here is a sine a, we can divide these two, and this is becoming 4 cosine a times cosine squared a minus sine squared a, which is 4 cosine cubic a minus 4 cosine a sine squared a. And we know this, and our aim is to change something into, so our aim is to change sine into cosine. And here is the square, which is really useful because we can now use the equation of sine squared a plus cosine squared a equals 1. Let's use this, which means that is equals to 4 cosine cubic a minus 4 cosine a bracket 1 minus cosine squared a, and that is equal to 4 cosine cubic a minus plus 4 cosine cubic a minus 4 cosine a, which is equal to right hand side, our right hand side. And now let's move up to hard level question. Well, let's change this into your hardest question. And it's not that hard actually, but you need to change a way to solve it. Because if you start from left hand side to right hand side, if you start like this, you will find that it is very complicated, and you can't find the direction about how to solve it. So there is one simple way, that we start from right hand side and go back to left hand side. So let's start from right hand side, equals 1 minus cosine 4x. And that is, let's use the double angle formula, which becomes cosine squared 2x minus sine squared 2x. And here let's consider that y1 is equal to cosine squared 2x plus sine squared 2x, and minus cosine squared 2x minus sine squared 2x. Well, here's the 2 here. Well, now we can subtract both of these two terms, and our answer will be 2 times sine squared 2x. And now we use the double angle formula again, which becomes 2 bracket 2 sine x cosine x bracket squared, and that is equal to 8 sine squared x cosine squared x, and that is equal to left hand side. And so we have done this question. Yeah, see, it's not very difficult unless if you start from the right hand side. So sometimes if you can't solve the question from left hand side to right hand side, you should change the other way. Okay, so that is all for today, and